you see the conclusion for yesterday class, we stopped the yesterday and the Puch-Fitty reaction. I will give you one more example for you. Puch means what? A purely alkyl halide. Puch-Fitty means mixed. One is alkyl halide, another one will be aryl halide. Will be mixed, right? The ethyl chloride will be reacting with sodium metal in presence of chlorobenzene. In presence of dry ether, we are getting alkyl benzene. Okay, just we have one more thing related to this one. It is nothing but purely Fitty reaction. Purely Fitty reaction. I think you will get an idea. Puch is purely alkyl halide. Puch-Fitty is one alkyl halide, one aryl halide. Fitty means what? Purely aryl halide. Means you take ARX aryl halide will be reacted with 2 moles of sodium. And again we have to take one more aryl halide that will be proceeding in presence of which one? Dry ether. Then what happening now? 2 sodium atoms, 2 halogen atoms is coming like this. After that what happening? Aryl group, aromatic group is connected with the aromatic group. Can I give an example? So what is the Fitty reaction explanation? Whenever aryl halide will be treated with sodium metal in presence of dry ether, we are getting biphenyls. How is that one? I will explain to you, see carefully. Better take it horizontally. This is what? Chlorobenzene, aryl halide, will be reacted with 2 moles of sodium. And take one more aryl halide, nothing but chlorobenzene. Okay, in presence of dry ether, what happened in it? 2 chlorine atoms, 2 sodium atoms is coming outside. After that, 2 benzene rings are directly connected through single bond. Check it here. Methyl connected with benzene through single bond. Like that, 2 alkyl groups connected through single bond. Like that, 2 benzene rings are joined together through single bond. Then we are getting how one benzene ring will come like this, connected with the one more benzene ring. It is calling as a phenyl. It is calling as a phenyl. So calling as biphenyls. These are calling as biphenyls. Okay, don't write by direct joining like this. Why? Because while involved in the chemical reaction, they are connected through single bond. This one, it is a wrong expression for them. All of you clear? So did you got clarity? Just I will write one example for you. Listen carefully. For example, CH3, CH2, Cl, 2 moles will be combined with 2 moles of sodium in presence of dry ether. What we are getting? 2 ethyl chlorides will combine with 2 sodiums. 2 sodiums, 2 chlorines will come outside. After that, what happening? 2 ethyl groups will join together. Nothing but C2H4 is connected with the C2H4. Is it calling as Puch-Fitty, Puch or Fitty? Puch. Why? Both are alkyl halides, only that's why it is calling as Puch reaction. Are you clear? And no, I am taking one more thing, second example for this one. It is nothing but C3H7C will be reacting with 2 moles of sodium and we are taking chlorobenzene. I am taking. Okay, what is this one? It is the alkyl halide, but it is the aryl halide. Mixing, crossed means one is alkyl, another one is aryl. Puch and Fitty is nothing but a Puch-Fitty reaction. Then what is the product ending? Here also what happening? 2 moles of NaCl will be eliminating. Then alkyl group is connected with that aryl group. Then we are getting C3H7 and benzene. Is clear? This calling as which one? Puch-Fitty reaction. Okay, next I will give you one more example. This one we can take. If you can take that one, we are getting which one? Biphenyls we are getting. That is purely aryl halides. We are involving in the reaction. That's why it is calling as which one? Fitty reaction. All of you got clarity here? Yes. Yes. With that aryl halide, alkyl halide preparation, properties, and everything will be over. Now we are discussing uses of the compounds together. So there are nothing but polyhalogen compound. What is the meaning of polyhalogen compound? It's an organic compound in which more than one halogen particle will be there. So regarding those compounds, they are having a lot of importance in our daily life. How is that one? What are the advantages, what are the disadvantages? We are discussing everything. So under this first compound, I am writing here, it is nothing but CH2Cl2. Okay, it is one of the organic halogen compound. What is the name of this one? Do you know? Just recheck it. How we are getting? First of all, you take methane. Will be involved in the reaction with chlorine in presence of sunlight. We did under preparation of haloalkanes. How it is going on? Free radical mechanism. Free radical mechanism is what? One chlorine radical, one H radical will becoming like HCl. After that, what we are getting? CH3Cl. Is it our product? No. We want one more substitution. Then what happening? CH3Cl still undergoing reaction with chlorine in presence of sunlight. Once you see the preparation, you will get it. Okay, again one more H radical, one more Cl radical will undergoing elimination. That H will be replaced with Cl. Then what we are getting? CH2Cl2. How can you tell this one? So this dichloromethane. How many carbons is here? 2. One carbon is there, but how many chlorines is there? 2. That's why it is calling as a dichloromethane. That's why we write down name. Name of this compound is nothing but dichloromethane. Shortcut we are representing or we are calling as DCM. DCM, dichloromethane. It is formed, or we can prepare this one by using methane. Reaction with chlorine in presence of sunlight, going mechanism through free radical mechanism, we are getting like that. Still it can go substitution. Then what we are getting? Right on, that is also CH2Cl2 still involved in the reaction with chlorine in presence of sunlight. What happening? One more hydrogen will combine with the chlorine. Then we are getting CHCl3. What is the name? Trichloromethane. Still has capacity. CHCl3 will involve in the reaction with chlorine in presence of sunlight. That hydrogen also can be replaced. Then we are getting CCl4. Now, right now we are discussing about this compound is nothing but dichloromethane is nothing but DCM. What are the characteristics and where it is useful to us? So first of all, together I am telling it is a colorless liquid. It is colorless liquid. And it having low boiling point. Because of low boiling point, what happening? Easily evaporating. Easily evaporating means is it volatile liquid or non-volatile liquid? Volatile nature. Volatile liquid. Due to its volatile nature, we are using this chemical as the one of the solvent in organic reactions. Solvent in organic chemistry. While doing chemical reactions, we are using this one as one of the best solvent. Why? Because no need to do anything itself, it is undergoing evaporation. Then separation will be easy. And can we discuss some other things? It will be used as a paint remover. For example, nail polish is there. If you want to remove that, you are applying one type of the liquid. That is nothing but DCM, dichloromethane. It is nothing but paint remover. For example, you have any metal sheet. Oh, okay, one color is there. You want to apply one more color. First of all, you have to remove that one. For that also we are using this liquid. And can you see some other properties of this one? It is showing effect on NCS, CNS. Means for example, if you breathe this liquid fumes, then what happening? It is showing effect on CNS, central nervous system. It will be affecting on central nervous system. Nervous system, means automatically you are feeling sleepy and dizziness and headache and different problems will be coming. And some other characteristics of this one, if suppose this liquid falling on our skin burning will be possible. Skin burning will be happening, and suppose those vapors or those liquid vapors is exposed to our eyes, we are getting eye irritation. Like burning and like the itching we are getting, eye irritation also we are facing, irritation. These are all special characteristics of this one. Let it be, all are not that much important, but one of the important is used as a solvent as well as paint. Okay, later we are discussing about another compound. It is nothing but second one, CHCl3. Already we learned preparation here, CHCl3. What is the name of this one? 3 chlorines is there. 3 chlorines means what? Trichloromethane. Okay, trichloromethane means is nothing but TCM. It is denoted by TCM. It is also can be prepared by halogenation of alkanes in presence of sunlight. Already we done that one. But what are the special characters of this one? It is also colorless liquid. It is also having which one? Low boiling point. Okay, due to low boiling point, we can it should be considered, or it should be having which nature? Volatile liquid. Okay, that's why based on this character we can use this one as one of the solvent in organic reactions. But what is the special? Okay, in olden days I told sometimes in olden days while doing surgeries operations they are using this one as an anesthetic. Means chloroform can be used. It is generally calling or commonly calling as which name? Chloroform. Chloroform is one of the anesthetic nature having by this one. That's why they are using in the preparation of the cough syrups. If you observe after drinking that cough syrups, whether cold or fever, whatever is there, if you are drinking that syrup, what happening? Immediately you are still feeling sleepy. Why? Because anesthetic nature having by this one. And this chloroform can be used as a preservative liquid for anatomical specimens. What is the meaning of anatomical specimens? Dead bodies, like plants and animals. If you are keeping that one in biology, botany and zoology labs, you are keeping in a special liquid. That liquid only nothing but chloroform. Preservative liquid for anatomical specimens. And like this, we are using so much in this. It is also showing effect on CNS, central nervous system. Definitely, if you are breathing much concentration, it causes lung problems and all these. And we have to see one more halogen compound is nothing but CHI3. What is the name of CHI3? Instead of chlorine, we are introducing iodine. It is nothing but triiodomethane. It is also calling as iodoform. Iodoform is the yellow color crystalline solid. Crystalline solid. But we observed in our daily life. Whenever some minor accident is happened, on that wounds we are applying one type of the liquid. Did you observe color? Yellow color. What is that one? Iodoform. Actually, it is available in crystalline form, but for our convenience, we are making it into liquid form. That liquid we are applying on that wounds, then it is one of the best antiseptic. It is acting as an antiseptic. This is important. So, iodoform is acting as an antiseptic. And later, we are discussing one more compound is nothing but CCl4. CCl4 is the last product in the halogenation of the methane. Already we learned it. What is the name of that one? How many chlorines? 4 chlorines with carbon. It is nothing but tetrachloromethane. Okay, but it is also calling as which one common name? Carbon tetrachloride. Carbon tetrachloride is mostly using the actually name is tetrachloromethane. So it is a last product in the halogenation of the methane. It is also colorless liquid. And having a low boiling point, but it has a heavier than water. Why? Water molecular mass is how much? just 18, but this molecular mass is how much? Carbon 12 plus 4 into each chlorine is 35.5. That's why the chloroform is heavier. Sorry, carbon tetrachloride is heavier than the poison. Later, we have to discuss some other important things. Is nothing but it is also showing effect on lungs. That's why it's creating lung cancer. If you breathe much this quantity, it's causing lung cancer. And where we are using this one? We are using this one in dry cleaning. We are using this chemical in dry cleaning, and also we are using this one in which one? Fire extinguishing. Fire extinguishing. Okay, these all the special characteristics of the carbon tetrachloride. It is also used as a one of the solvent in most of the organic reactions. Are you clear? So now one of the important point that I will discuss under chloroform. Under chloroform we have one special character. So the chloroform is easily react with the atmospheric oxygen in presence of sunlight. We are getting very dangerous gas we are getting. How is that when you see carefully? Take 2 moles of chloroform, 2 moles, 2 carbon atom, 2 oxygens and 4 chlorines is becoming like 2COCl2 we are getting. Okay, how many hydrogens coming outside? 2 hydrogens and 2 chlorines is becoming like 2HCl. What is this name? Carbonyl chloride. Carbonyl chloride. This carbonyl chloride only we are calling as phosgene gas. Phosgene gas. Are you getting on? So this chloroform is very dangerous. If it is entered into atmosphere, it will be combined with oxygen, which is in presence of sunlight. It is producing very poisonous gas. Is nothing but carbonyl chloride is calling as a phosgene gas. Are you getting on? So then this is very dangerous. That's why this chloroform should be kept in dark bodies, dark colored bodies. Why? It should not interact with the sunlight. And that too, it is always stored full bottles. Why? Because in that bottle it should not leave any gap. If you leave any gap, what happens? Oxygen will be present. That's why to avoid this formation of the poisonous gases, carbonyl chloride is nothing but poison gas. So to avoid the formation of the poison gases, it should be kept in dark color bottles. That too, complete bottles you have to keep it. All of you clear? Yes. Okay. Yes. Another halogen compound is nothing but freons. Already you learned in first year and last chemistry, environmental chemistry. There we learned freons. What are the freons? Chlorofluorocarbons. Chlorofluorocarbons. So shortcutly we are calling them as CFCs. Yes or no? CFCs. Chlorofluorocarbons is calling as a freons. Especially these also nothing but halogen organic compounds. See the concept carefully. Halogen organic compounds. Okay, these dangerous chemicals or gases will be produced from the refrigerators like ACs and whatever cooling devices will be there from refrigerators like freezers. From all these, we are getting which gases? Freons we are getting, they are nothing but chlorofluorocarbons. You know very well, just by seeing only we can tell in that fluorine is there, highly dangerous for human beings as well as atmosphere. So one of the most known freon and dangerous is nothing but CF2Cl2. What is the name of this one? Difluoromethane. Only one carbon methane. In that 2 hydrogens is replaced with fluorine, 2 hydrogens is replaced with chlorine. That's what is calling as difluoromethane. It's a very dangerous chemical. So it causes very damage to human beings as well as atmosphere. Especially it causes depletion of the ozone layer. Depletion of ozone layer. Ozone layer. You got it. You already studied it. but how it is causing damage to the ozone layer? You know, ozone layer is helpful a lot to us to protect us from ultraviolet radiations which are coming from the sun. If there is no ozone layer, what happening? Ultraviolet radiations directly falling on human beings, like whatever is there. So after falling on our skin, we are getting so many health problems as well as skin diseases we are getting, especially skin cancer also we get. To avoid all these, ozone layer is helpful a lot to us. But that ozone layer is damaged with chlorofluorocarbons by using of refrigerators. Okay, how is happening? We will see. Take CF2Cl2. So in that ozone layer is group of ozone particles. Yes. How damaging is happening? I will explain to you. See. So between C and F, short bond, strong bond. But between carbon and chlorine, long bond, easily break down. Then what happening? We are getting the first of all you write down breaking of this one. CF2, Cl radical and Cl radical will be happening in presence of sunlight. Automatically decomposition will be happening. After that, what happening? The Cl radical will be reacting with the ozone, which is present in the ozone layer. Anyway, chlorine radical is coming from which one? Freons. Okay, then what happening? Chlorine will be combining with the oxygen, is becoming like chlorine oxy radical plus oxygen gas. Okay, anyway, one ozone molecule is converting into oxygen molecule, comes into atmosphere. There, what happening? Hole is created. Why? Because we pulled one ozone molecule, automatically holes will be created. So after this still process is going on. CLO, still it is reactive particle, chlorine oxy radical. Again it will be reacting with the ozone molecule. Then what happening? It will becomes like Cl radical plus oxygen and 3 oxygens is becoming like 2 oxygens. Finally, what happening? You observe or no? 2 ozone molecules are becoming like 3 oxygen molecule with the reaction with chlorofluorocarbons. Finally, what we conclude? Okay, by reaction of freons with ozone, it will be converted into oxygen. Then, in that ozone place, holes will be generated. Through that holes, ultraviolet radiations will be falling on Earth's surface. This causes lot of damage. This whole process only we are calling as depletion of the ozone layer. Last and very important compound we have to discuss under this lesson, it is nothing but the DDT. DDT. So what is the full form of DDT? So it is nothing but P comma P dash. Right here. P comma P dash, nothing but para position. P comma P dash dichloro diphenyl trichloroethane. It is the full form of DDT. What is that one? PP dash. PP dash means it represents a para position. PP dash dichloro diphenyl trichloroethane. You will come to know by seeing the structure. So first of all, DDT, how you are preparing? First of all, we are taking compound is nothing but trichloroacetaldehyde. Acetaldehyde. What is the formula of acetaldehyde? CH3CHO. Yes or no? CH3CHO. Yes, this is calling as acetaldehyde. But trichloro means what? 3 hydrogen atoms is replaced with chlorine atom. This is calling as trichloroacetaldehyde. It is also calling as chloral. It is also calling as a chloral. It will be reacting with which one? Para-chlorobenzene. Yes, para-chlorobenzene means we have to take chlorobenzene, we have to take like this, and one more chlorobenzene we have to take like this. Okay, like this we have to take the 2 molecules of chlorobenzene. But at para position, what will be there? Hydrogens will be there. What happening anyway? From this benzene ring 1 hydrogen, from another benzene 1 hydrogen, and like this water elimination is happening. After that eliminating water, what we are getting again? C on that 3 chlorine atoms. Yes or no? After that CH. Okay, two bonds, one bond with one benzene ring. Yes or no? Like this we are getting, and one more benzene, one more bond with another benzene ring or another chlorobenzene ring. This is only we are calling as DDT. Now you will get it. What is the position? Para position. Para position. Okay, P. This is P dash. PP dash. Dichloro, diphenyl, trichloro. How many carbons? Two carbons. Are you getting it? P dash, dichloro, diphenyl, trichloro, ethane is calling as DDT. It is acting as a insecticide. It is acting as a insecticide. Insecticide is what? It is useful to kill the insects. But here problem is they banned this chemical using as a insecticide. They are not using nowadays this chemical as an insecticide. Why? Because the DDT is a highly stable compound. Highly stable compound. Okay, for example, you use this one as a cockroach killer. Okay, cockroaches are eaten, this one they died, but the compound is not decomposing because highly stable. Okay, after dying the cockroaches are eaten by cats. For example, rats. Again, rats also dying. Again, rats are eaten by cats. The cats also dying. Again, cats are eaten by dogs. The process is going the chain process. That's why they banned this chemical using as a insecticide. Why? Because the DDT is a highly stable compound. After taking this compound by any animal, the compound is not involving in the metabolism. Still, it is DDT only. That's why the deathing or dying process will be chain. That's why they avoided using of this chemical. All of you clear? Yes.